Okay, good afternoon. So today we are going to talk about the GNSS baseline processing using the Leica Infinity. So to sit with me there is Katie and Christine.
Hello. Hello, everyone.
Hello. Okay, so let's go for it. So when we do the so-called the GNSS processing, the baseline processing, where most of the time the people will do the planning. When they do the planning, we have a subprogram is called satellite availability. Okay, another thing probably you guys we really need to look after is the antenna files. Okay, and I point out here is important when there's really mix different manufacturers and models. Okay, and then we talk about the baseline processing, how to do it, and then we try to decode these baseline reports. So satellite availability is a subprogram under the Leica Infinity. Okay, later I will show you, probably maybe now I can show you. Will take some time to load up the program. So can you see it? Not yet, huh? Yeah. Okay, good. So I just opened one of the project, okay, as an example, and then later on I will send you the PowerPoint, and I send you some of the sample data as well, so that you can play around. And all these will be showing now what I'm doing this project. Okay. So now you have a let's say you have an approximate point, okay? So where you want to do the post-processing, okay? Occupy the static points, okay? Maybe using Garmin, whatever, you can key in those so-called points. Okay, in the Infinity, you can right-click the mouse on the point, okay? And that's called satellite availability. And then the Infinity will launch another window. Okay, because this point you have a coordinate, that's why you approximately show you where are the points. So in this case, you can see here, okay, there's a point called CP01. Exactly, that's the one I just right-click mouse and say, generate this point in here in order to check the supply availability. So here you can key the date. Okay, this is the point. Okay, and the coordinate of the point, and then you can see which day you want to plan to do the survey. For example, you want to do it on maybe 8, okay, and also at 8, okay, cut off angle. So we are lucky, okay, in our region in Asia. So we have a 5 satellite system here: GPS, GLONASS, Beidou, Galileo, and Q is a SS. Okay, so anyway, just say create. Change to the 7. Okay, say create. So now actually what happening, the system, if there's internet connection, it will go to the Leica server and grab all this almanac file, okay, and display to you. So this information, for example, number of satellites at that location. Okay, you can see there's a GPS, GLONASS, Beidou, and Galileo. QSSS in this case is not available because the location is in the Europe, okay, in the Switzerland. That's why it's not showing. If your location is in Asia, okay, it will show QSSS, the satellite also in here. Okay, in here you can do your so-called your mission planning. So see which time to which time you would like to do the survey. Okay, so this important graph. Okay, you need to manage the time. Okay, and then this is showing the satellite view visible during from which time to what time to what time. Okay, and the dot value, this another surveyor is concerned about, because some of the government authority, they controlling a dot value. So if bigger than 3, or they not allowed to, they are not accept this data. Okay, so there's a G dot, there's a P dot, H dot, V dot. Okay, so it depends. Like in the Singapore, the Singapore Land Authority, they will look at the P dot value, and they will say, oh, if the P dot is bigger than 2.6, this will not accepted. Okay, so there's another satellite information, elevation, azimuth, okay, sky port. Okay, so this is really give you to do the planning of the when you should go out and do the survey, the static survey. Okay, any questions about this satellite availability? Okay, if not, I will go back to the PowerPoints. Okay, I need to toggle between the PowerPoints and the application, huh? To the PowerPoint slide. Okay. Guang, your background is a bit noisy. Okay, so I go back to the slides here. Slideshow. Okay. Another thing is important talk about the accuracy. Is really need to look after this antenna file. This. So yeah, there's a technical issue, huh? Hmm?
Wants to show the PowerPoint.
I want to show PowerPoint. Okay. Wow. Okay. Need to practice more. Okay. So antenna file. Okay, that's antenna file. We should go there and visit. So you can see there's the link. Okay. If you copy and paste this link, you should write this antenna calibration website. Okay, and from there you can download the so-called calibrated antenna file. Okay, after you download it, it may as a text file. Okay, but you need to change the extension .atx. Okay, and then you can import to the Leica Infinity. Okay, so there may be some question asked why this antenna file is so important. Okay, yeah, it is important because when you want to measure correctly with other receivers, is we need to understand other receivers the antenna offset. Otherwise, we've got some of height or problem. Okay, so you see the antenna phase center. Okay, the question is, where is the signal we receive by this antenna? Okay, and then we have a so-called antenna reference point, or for us we call mechanical reference point. Okay, so there is those parameters we need to well define. We need to well define, and this organization like the NGS, like Joe++, they are doing this measurement and define where is the offset. Okay, phase center offset, and how good of your phase center. Okay, so there is a talking accuracy of this phase center. Okay, and some of them, if the manufacturer is not so good, okay, if you come to sometimes we come to about cm. Okay, the one term I'm using is called so-called the phase center offset. This means the phase center and to the point you contact whatever the monument. Okay, maybe carrier, maybe it's really the monument. How far away the vertical offset from the phase center to your point. Okay, and then second thing you talk about the phase center the variations. Okay, and how good your phase center, because as you know, okay, the satellite will be moving, okay, from up and down, forward, down, whatever, so up again. So their elevation will really affecting your phase center. If your phase center is no good, you can imagine the phase center is really moving. Okay, this phase center offset talking about the contact point, the physical contact point to the phase center. Okay, and this is some of example talking about the phase center variation. Okay, so we put the 90-degree in here. We are assuming that this is where the best reception. Okay, so the phase center should be perfect. Okay, so but once this elevation is low elevation, okay, so then you can see some of the change of the phase center. So it will change. Okay, so that's why all these GNS antenna should calibrated. Okay, and some country they not accepted the antenna calibration file from the manufacturer, so they must using so-called the third-party antenna calibration file. Okay, there's example. So let's say this satellite at a low elevation, the phase center variation is like this, but when they going up, okay, so the phase center in mm it will be different. Okay, from -1 mm to +2 mm. Okay, and all this information will, as a result, will be affecting your post-processing. Okay, the data, the accuracy. Okay, that's an example showing you not just elevation. Nowadays, those so-called uh, the antenna calibration organization, they will do the elevation, of course, and also plus the azimuth. Okay, okay, this elevation from zero elevation, zenith angle. Okay, from 0 to 90. Okay, this is azimuth. Okay, from 0 to 360. It's a really in 3D. So at the antenna at specific elevation and as specific azimuth, and this much the kind of phase center radiation. Okay, so what will be happen if you really ignoring or just this called not really care about the calibration or the antenna calibration? It will cause when you do the long baseline measurement, okay, when you're combining all different antenna model and brands, okay, and sure you have the high, okay, errors. So the antenna, the GNSS measurement, the antenna file is playing very important part. Okay, sometimes the people, hey, the horizontal is correct, but my vertical is 10 centimeter or difference. Okay, I can tell you most of the time it's because the antenna file is not used correctly. Okay, when you do the post-processing at the time. So there is some example telling you about the organization doing the antenna calibration. Leica, we are using Geo++. Okay, and there is a so-called is a profit-making company. Okay, of course there is another organization. For example, university. They would like to understand how good the manufacturer making this antenna. They will have their way to do so-called antenna calibration. Okay, this just these two as example. There's other organization also. Okay, like I just mentioned before is NGS, IGS. They are doing antenna calibration as well. Okay, this is a very quick workflow when we're doing the kind of GNSS processing. Okay, so I just go through quickly. Okay, of course we need a new project with the coordinate system. Okay, and then we import the GNSS raw data. Okay, we need to make sure using correct antenna file. Okay, especially when you mix with different brands antenna. Okay, and then we need to make sure the antenna height are correct. Okay. Okay, and then we key in the control point coordinate. Okay, if they have a standard deviation, okay, the people will ask why I need the standard deviation, and this is for the adjustment later on. Okay, and for the signal strength, later I'll show you. And now I quickly gone through this workflow first. Okay, we can do the signal strength check. Okay. And also we need to check the processing parameter before we press the process button. Okay, after process, we need to understand the baseline reports. Okay, and then after that we are happy already, then we store the baseline. So next thing we can go to adjustment. Okay, then we can check the adjustment parameters and then we adjust. Okay, do the adjustment and read the adjustment report. Okay, and then we store the adjusted result. Okay, so I put the remark here. Okay, if there's more than two reference point or control point in the field, you do the so-called static survey campaign. Okay, you really need to do the baseline processing of these two control point first before you do the buffer point baseline processing, because you can imagine if this control point is a good quality, you check it, then it's fine. Okay, then you can continue to do the so-called other buffer points baseline processing. But if one of control point somehow is have problem, okay? Then through this exercise, because you do the baseline processing, you find it the difference. If this difference is very high, very big, so you need to think about so which control point will have problem and how you do of the problem control points. Okay, so that's why before any so-called rover point processing, if you have the two control points, you really need to do checking first. Okay, checking your control point whether they are good. Okay, if they are good, then we can carry out the rest of the rover point measurements, baseline processing. Okay, so after processing, there's a button I will show up later. Okay, I can show up later in the Leica Infinity. And there's some cases you will find out why my GLONASS cannot process, only can process GPS data. Why I cannot process the Beidou data? You need to there is some kind of warning or error showing in Infinity. Sometimes it tell you there's a missing of the orbit or navigation files. So then what you can do, you need to go to download all these navigation file, okay, from those IGS or NGS stations, okay. Okay, and there's some of the data, the orbit data. If let's say you are really carry out very precise or high accuracy measurement, okay, and your customer need to wait for the so-called the precise ephemerals, okay, and then they have to wait, okay, wait about 2 weeks, okay, and then you can download from the website, okay, and get the precise ephemerals, okay. So these are processing parameters I will go through later when we do the processing. Okay, strategy, advanced, auto processing. These are very interesting. I would like to go through with you. Okay, now I would like to switch back to the Leica Infinity. Okay, so now you can see the Leica Infinity. This is I just show you is about the shutter availability. Okay, happy that I just close it. So back to here, there's a view. So when you import data, it look like this. Okay, you can can you see the gray dot line, gray color dot line? Okay, here is a suggested baseline. Okay, so by the system they can calculate how many baseline you can generate it. Okay, so it's available now in the new Infinity version 3. Okay, because version 3 have the auto processing. Okay, then now I go to the inspector. Okay, inspector, I can go to GenSS tab. Okay, and here you can see the points, which points control point for this project only have one control point, the rest is the rover points. Okay, and like this case, there's no another control point in the field, and there's no choice. If there's two control points in the field, as I mentioned before, you really have to process the two control point baseline first. Okay, make sure they are in a good quality. Okay, so then I go to processing. Okay, so you can see there's a reference, there's a rover, and there's an octo. Okay, we do it one by one. Okay, and once you import the data, what you need to do, okay, you need to choose antenna set. Okay, so you need to choose what are the antenna set you're going to use. Okay, here you can see you can choose different antenna set. So because we entering, we have import the NGS antenna. So and this is the latest one. Okay, you can go to the website and download and save and then import to Leica Infinity. So, but for this case, we use this one. We feel more comfortable. Okay, so make sure the antenna set is correct. Okay, so next thing is antenna height. Okay, you should think about just now I mentioned. Okay, we should really need to look into antenna height. So for some cases, there is a height, the so-called using the high hope, you may have a 0.36 carrier offset. Okay, then you key in the reading from the using the measuring tab. Okay, so that the result you should get this is the total antenna height. Maybe I show you this one. Okay, say for example there's a GS16. Okay, if I go to antenna height, so you can see, okay, these are the high meter reading, and this is the carrier offset. Okay, you remember the high hope? There's a offset value 0.36. So when you add in together, it's a 1.508, and this is the antenna height. Okay, so anything, especially of some of the user, as like the GS15, GS10, whatever, you can log the raw data without the controller. So what the people doing, they just press the power on, the power button, okay, and once is the GNS receiver is working, okay, tracking, so then just track. But one thing you need to aware is come back to the field, import the raw data, you need to key in the field measurement of the antenna height. Okay, and now you have a chance to key in before the processing. So important, okay, choose the antenna set. The second thing you need to do is make sure the antenna height is correct. Okay, so now next thing I would like to show you is before the processing, you really to have a overload signal strength. Okay, so there's a small arrow here. Okay, you press it. So it's telling you what satellite you have tracked during your occupation. Okay, G for GPS, R for GLONASS, okay, C for the Beidou for the China, E from Galileo. Okay, then there's a small icon here. So you press it. Okay, so this signal to noise ratio, so they're using the green color means it's a good signal. Okay, so it just really quick overlook how good of the data set, the data. Okay, make sure there's no red color. Okay, if there's a red color, you have to be careful. And the next button, the next icon here is showing the elevation. Okay, how this satellite moving. Okay, from low elevation to high elevation. Okay, and sometimes this can explain to you why the signal is weak, because they are at the low elevation. Okay, and this data set is okay, but in the real life, probably you can see the intermittent data. Okay, and then color will be is in the orange. Okay, sometimes it's in red. Okay, but this is just indication before you gone through the view process. If you know this satellite is not really good at all, then the next thing you should exclude it before you do the processing. Okay. Okay, so next thing is set. If there's like this case only have one reference, what I need to do, I set the reference. Oh, that wrongly, no problem. Okay, you can here selection. Okay, go to control, right click mouse. Okay, and see there's a reference. Okay, and you highlight this one and then press the shift button. Highlight the CP06, right click mouse, you can see rover. Okay, so after I do the selection, you go to the view, you can see there's the going to process baseline is showing. Okay, from this station, you process the other so-called rover points. Okay, then we need to look at the data. Okay, these are settings. You can define your cutoff angle, of course. Most of people, they're happy with the cutoff angle at 10. Okay, the sample weight, you can say 1 second. Okay, you can say use all. All means it really depends on your data set. If your data set is a 30 second, it's 30 seconds. If a data set is 1 second, it's 1 second. Okay, but let's say you log the 1 second data set. Okay, but I would like to pause and spread 10 seconds, no problem. Okay, but I know the data set is 1 second, that's why I choose 1 second, or I use all. Okay, satellite system using all. But let's say if you know something is not right, okay, you can see the menu selection, okay, and then go to select. Okay, this is a GPS. Maybe you know, okay, this GS25, G25, 29 data is no good. Then you uncheck it. Okay, and then you press OK. What does it mean? So this meaning the system will not use this GPS G25, 29 satellite to their data for processing. Okay. Environments, you can most of the time the people is for the normal surveyor, they're happy with the broadcast environments. But if let's say the government customer or the government sector, when they set up the control point, the control network for second order or first order, or even sometimes third order, they would like to have precise environments. Okay, then you can go to the website I just showed you. You can go there and download those precise environments. Okay, antenna, we choose already. So these are data, huh? So what are data? How we use data? Okay, that's okay. The next one is called strategy. Okay, most of us would like to phase fix because it's the highest accuracy we can achieve. Okay, but for some of the case, or especially those university customer, they really want to see, oh, I would like to see your flow solution. They will force it only using the code data to do the post-processing. Okay, but as I mentioned, we just using the normal one, phase fix. Okay, you can see there is a solution optimization, the automatic. Okay, all this we should choose. When that's automatic, we choose automatic. Okay, for this one, the tropospheric model, we should use this one. This is the GPT-2 model. This is a global pressure temperature, the second model. Okay, it's do it globally. As I'm not wrong, the study start from 2001 to 2010. Okay, it took a long time to study of this troposphere, and that's why they make the model, and Leica Infinity use this model to apply this tropospheric model to our measurement. Okay, atmospheric model, automatic. Okay, that's okay. The next one I talk about is advanced. Okay, automatic means wherever the available data from different satellite, we're just using all. Okay, of course there's algorithm to do the filtering of the bad data or the intermittent data, or there is the cycle sleep data will not be used. Okay, but usually the people use automatic. Okay, the minimum, the ionosphere distance is 15 kilometer. There is okay. Actually, what does it mean? Okay, actually, you hover this one. It give you the description. Because there's an ionospheric model behind. If your baseline is longer 15 kilometer, okay, and the Leica Infinity will apply this ionospheric model to your baseline. But this is so-called ionospheric model applied, then what happened is the data will not so clean as L1, L2. Okay, so less than 15 kilometer, Leica Infinity will be using L1 and L2 data to do processing. Okay, but if your data, your baseline longer than 15 kilometer, okay, the impact of the ionosphere is high. Okay, at that time the L1, L2 give you your result will not be good. Okay, and by our experience, so 15 kilometer is a good number to have applied this ionospheric correction model. Okay, this 300 kilometer actually is because previously is a shorter 200 kilometer. Now it's a longer because now we have more satellite. Okay, before we probably have the GPS, GLONASS, okay, very minimum. So now we have Beidou, we have Galileo, in Asia we have the QZSS. All these, in terms of accuracy, will not improve so much. In terms of accuracy, will not improve so much. But in terms of a baseline length, we can have a longer baseline, can be manageable. Okay. And then this is the minimum distance for 5 minutes for so-called rapid static. Okay, allow this so-called wilding fix is something like the XRTK. Okay, so we can allow the XRTK solution will come in the post-processing mode. Okay, normally we put automatic. Okay, happy? We press OK. So after that, we haven't talked about this auto processing, because we just very simple to do 1 base and 6 mover processing. So now I just press this process button. So now we'll process this single baseline. So far, any questions? Any questions, gentlemen? Because now it's processing, so I need to ask questions. Okay, so now we can see there is an exclamation mark. As I mentioned, we will tell you the FMS is not available for this coordinate for this satellite, and that's why there is an exclamation mark. It's like this case, there's a solution for this one. Okay, but anyway, let me just quickly open the. Okay, you can see it's not stored yet. Okay, everything we should check the baseline report, and then we feel comfortable, we feel it's reasonable, then we save. Okay, we'll store. Right click mouse, we go to report. There is a summary and detail. Okay, summary for me is more than enough. Detail is very detailed. Okay, let's open the summary report. Okay, so this is a baseline processing report. Okay, tell you the project details. Okay, because I'm using KT's laptop, that's why it's a KT's name here. Okay, tell you coordinate system, which one you're using. Okay, and then tell you about the processing parameters, because when some of people will give this report to the local authorities, they need to know what is happening. Okay, then there is a result. Okay, what the receiver is using, what antenna they're using, what the serial number for the base and rover. Okay, what the control point coordinate. Okay, rover coordinate. Okay, so they're showing, and they will show in the varying covariance matrix. Okay, for GPS, always standard deviation is very high. Okay, it's very high. Okay, so we have to be careful when especially we mix the adjustment with the total station and level data. And tell you the ephemeris is in broadcast, It is a graphic telling you how many satellite using for this period of time for this baseline. Okay, and this is a dot value. Okay, this is very interesting. Okay, I hope you can understand this ambiguity statistics. Okay, because it's really telling how good of your data set. How good of your data set. So what's ambiguities for here? Mention about number of ambiguities. Ambiguities are talking about the integer wavelength from the satellite to your receiver. Okay, then you can imagine. Okay, there's a no only one L1. Okay, there's L2, L5, and then there also the GPS, and there's also GLONASS. There is a Beidou, there's a Galileo, then QZSS. So the ambiguity, the number nowadays is more than before. Okay, so the total means, do you see the total clearly? Maybe I highlight this one here. Total. Okay, total means here. So by this set of data, you should have this much ambiguities. Okay, but in the reality, okay, by the Leica Infinity, we can calculate, we can fix these ambiguities. So these are total number, and these are the number we can fix using Leica Infinity. Okay, the best or the perfect case, the total number equal to the fixed number. Okay, so as I mentioned, the ambiguities is really talking about the integer of wavelength from the satellite to the receiver. Okay, and also we should consider the different satellite and different frequency. Okay, and also different satellite system. One thing I would like to point out here, probably I ask you, if I have a lot of these ambiguities, what do you think? What do you think? Is it a good thing or bad thing? Okay, the answer actually is depends on the time. Okay, if you have a longer time, of course, your ambiguity will be more. The total number will be more. Okay, because the satellite up and down. Okay, it will happen. Okay, the ambiguity will increase. But for example, you log the data, but ambiguity just within 1 hour, the ambiguity will shoot up to 2,000, for example. Okay, and what does it mean? This means there's a lot of ambiguity. Okay, during this observation. Okay, means there will be intermittent of the tracking of the satellite, the same satellite, for example. Okay, so for example, there's a tree. The same satellite at the beginning, they don't have blocking by the tree, the signal. Okay, so there's one ambiguity. So when the satellite raise up, okay, and then blocking by the tree, so then the system will count this ambiguity completed. Okay, so then after a bit, so the antenna, the satellite, we can see by the satellite again, so you can see by the receiver again, and then the ambiguity will be the new one. Okay, so ambiguity, you can imagine if there is a case, if there's a lot of obstructions or a lot of multipath, okay, will be cause a lot of ambiguity. Okay, so when you look at ambiguities, you need to think about how long your occupation at the station at that point. Okay, so you can see at a short time a lot of ambiguities. This means the environment is not so bad, not so good. Sorry, not so good. Okay, and that's why a lot of ambiguities. Okay, so the system counts many times ambiguities. Then we go for the so-called fix. Okay, this independent fix and the possible independent fix. Okay, possible means same as similar to the total. Okay, based on the data set, okay, we can see we can possible to fix 1,275 solution. Okay, And independent fix is really we can do 1275 fix. Okay, this means our data is good. Okay, we can fix the same number, okay, as a possible independent fix. Okay, so like this case, you can see the Beidou, because the data is to be 1,200, but there's a no, because as you look at back the data for the Beidou only have 2 satellite. Okay, that's why I cannot fix it at all. Okay, so more independent fix is better. Okay, this independent fix, you can treat it as the smart check for RTK system. Okay, smart check. So this means there is a checking compared with the ambiguities or the solutions 1,275 times. Okay, and also you should see the average time between the independent fix, about 6 seconds. Okay, so shorter is better. This means we can do the calculation, compare the ambiguities, compare with the solution, same as before. If yes, we give a check. Okay, fix. Okay, there's one fix. Okay, the time is about 6 seconds. Okay, so shorter time is better. If you can, some cases, if you do the baseline processing, it can go to minutes. Okay, have this impedance check. Okay, this means the data set is no good. Okay, it take longer time to do this independent check. Okay, and there is epoch fix. Okay, for the GPS, we talking about for GPS, for Galileo, for Beidou, and also talking about from different frequency. Okay, the epoch for the L1 is 99.86. Okay, L2 also, L5 99.84. Okay, all this is the fix. Okay, what we can fix. Okay, and then you can see not fixed. So the app together should be 100%. Okay, and there is a not fixed. If there's a not fixed, because of contradiction. Okay, contradiction here means the solution or the solution is not same as a previous one. So like the smart check. Okay, if you fix the solution at the beginning, okay, we will not give you the smart check until we can do the second solution, and we compare the first and the second solution. They are identical, are the same. Okay, and then we so-called the smart check coming in. Okay, if let's say the first one is the answer A, the second one is come with the answer B, and this for here is called contradiction. Okay, so the answer is different from the previous one. Okay, not fixed because of missing phase. Missing phase means we don't have data, the phase measurement from the raw data. Okay, all data is here is good. Okay, so those are the importance. I spent the quite time in here to explanation to you, because this is very important information in terms of processing baseline quality. Okay, from here you should know how good of the data. Okay, no worries. Okay, there's the PowerPoint slide, and or there is the PDF to give another description and example. Okay, later we will upload to the link. Okay, you click on the link, you can download from there. Okay, because we run out of time. Okay, so I close the baseline report. Okay, so now haven't saved yet. Okay, and you will see like this. Okay, have an exclamation mark here. There's a warning. Okay, but it doesn't mean the result is no good. Okay, it doesn't mean the result is no good. You really need to look at, open the baseline report, have a look at it. Okay, if you want to get rid of this exclamation mark warning, what you can do, you can go to download. Okay, you go to download page. Okay, you based on the point you take and find out the reference station data. Of course, again, this is not in Asia. This is in Switzerland. Okay. So then what you can do, you can click on this one, the base station. You can see the base station. I click on wherever you highlighted. Okay. And what you can do from here, you can say right click mouse. You can go to download. Download what? What you can download? You can download precise and famous. You can download navigation files. When you press start, they will download. Okay. After download, okay, the system will be automatic import to your project. Okay. Let me try. Okay. So remember, this is the precise and famous, and this is a broadcast. Okay. So all this data will be downloaded from this so-called reference station. Okay. And then later on, you will import to this project. Again, internet. You need to have internet. You need to have internet. So now it's waiting for import. Now it's downloading. After import, you say imported. So what happened is if after imported, you really want to do, you can do the process again. Process the baseline again. What I mean. If one thing, okay. Okay, so it's imported. Okay, done. So you download already. You download what you download. You download precise and famous navigation files. Okay. So now let's say now I've installed this result. Never mind. Okay, I go back again. So because I have the import the navigation file and precise and famous, so I can go to strategy or data. I can choose precise and famous now. I press OK, and I do the processing again. So you are not save the baseline if you not drag this result to the Leica Infinity as the baseline information, the final result. So that's why I need to do the so-called processing one more time. It's okay. Are you guys following? Oh, okay. Something is not really right. Okay. Okay, missing the orbit data. Okay. So all this is really depends on the just now the reference station, whether they have really have the data about like for example, you need to check whether this reference station have the Beidou tracking or not. Okay. Let's say we are happy already. Then we highlight, we just store. Okay. After store, you can see this dot line just now is just now the dot line now become a solid line. This means you have saved your baseline result into here. Okay. But since we have, but now the new function have a so-called automatic processing. So we can utilize this automatic processing to generate the rest of the result, the rest of this so-called gray color dot line. Okay, we want to have a process. Okay, and do the system by itself. Okay, I go back to inspector, go to GenSS. Okay, go back to the GNS interval. What I need to do, I need to highlight all these points. Then now I change to octo. Okay, you can see it changed the blue color. Okay, and you go to view. You may not see. Okay, there's a blue color. The background dot light become a blue color. Okay, and now I would like to talk about auto processing setting. Okay, and here again 30 seconds means 5 minutes. Okay, the maximum baseline 200 kilometer. Okay, we compute the baseline normally is unchecked. Okay, because some of the baseline we compute again with the low class of the navigation file. Okay, that will be a problem. Okay, so but we would like to compute the baseline between the control points. Okay, and we will compute all the possible baseline, and then there's an option called independent set. Independent set is really just like what we have just did. Means the number of unknown minus 1 is equal to number of baseline. Okay. Then we talk about strategy of which baseline processing first. Okay. I guess in our region, when we do the so-called the baseline processing or baseline occupation static measurement, so most of the time we will go to the site together, okay, and then when we do the occupation, we will inform each other, okay. For that sense, the duration should be not used, then should using the short slope baseline. What does mean short baseline? This means they will using the short baseline. I mean, use depends on the baseline length to process which baseline first. Okay, shorter baseline will process first. The longer baseline will process later. Okay, and same with duration. Duration also we will choose a longer duration process first. Okay, and duration here we're talking about the common duration. The common duration. Okay, for example, this one duration, of course, is from reference station data. Okay, the duration from this one. So the system, if I choose duration, the baseline will from this one will process this one first. Okay, and the next session will be the common duration, also this one with this one. Okay, so basically, then the next section is probably the CP4 to CP1. Okay, it's really comparing duration between 2 points. Wherever the duration is longer, so this strategy you choose longer duration, if you choose those common duration longer will process first. Okay. So then we talk about section by section. If you have two control point or reference station, okay, what it can be done by this option, okay, it will process the baseline from one reference station first, okay, after that, and move to another control point, okay, and do another so-called baseline measurement, okay. So allow to flow solution, I don't check it because we should always using the high accuracy means phase fixed solution to get as a reference. Okay. Okay. So this another option is called set the interval to octo at the import. We don't want to do that. Okay. So now what I can do, I can highlight this one. You can see the there's option when I choose these points as doing auto processing. So this suggested baseline all come up. Okay. So what you can do now, you highlight the points, okay, and then processing. This time will take longer time to process because the data is quite a lot, and also the baseline is quite a number of baseline also. Any questions so far? Okay, so at the time, processing the time, so I may go to the PowerPoint slides. Need to show this quotation. This one. Okay, thanks for taking. Okay, so this is what we just mentioned, but this strategy is really depends on your data set. Okay. Okay, there's my suggestion. When we do the baseline processing, if we have two control points, we really need to check the two control points. Okay, if the control point is one of the control points no good, okay, you have two options. One is we move this control point out, okay, or you treat this so-called point, so-called the control point as a unknown point or removal point, okay, and do the processing, and then we define the new coordinate of that point, okay. So if the control point checking is good, then we can go to the reference and rover measurement, just like what we do just now. We set the reference and the rover, we process first. Okay, we process. Okay, after process, it's like this. Okay, we save, we store it. Then all individual unknown point should have the fixed solution. Okay, and show up on the navigator showing like this. Okay, all fixed. Okay. Then next step is doing is just like what I'm now doing now. Okay, so I need to change all this point to the octo, to the blue color. Okay, and then we show you all these possible auto processing baseline. Okay, and then we process data. Of course, you need to define your parameters. Okay, define your parameters. Okay, after processing, you store it, you become like this. And because those points measured more than once, okay, more than once, then you can see the icons change from the face, okay, from the cross fixed measurement, and then to the average, okay, because this point have more than two solution, okay, two answer, and sometimes it will come with the exclamation mark, means your mean value, okay, is not matching or out of tolerance, okay, and then at that time you really need to look into it, why this average is out of the tolerance, okay. After processing, as we mentioned before, these are the baseline report and talking about ambiguity statistics. Okay, so these are the information you really should understand what does it mean. Okay, especially when you talk with those customer, they really interested to know. Okay, if of course some customer they not really want to know too much in detail. Okay, that is fine. Okay, but what we're trying to give you more is in case you have facing some of the questions from the customer talking about, hey, what does it mean this independent fix? Okay, then you have a answer. Okay, show your professionalism. Okay, so now it's a process already. Okay, so the next step I just save, for example, store the value, the baseline value, since all is a fix. Okay, you can see now all become to circle. Okay, circle means is have average value more than one measurement. Okay, so my question to you, when I click on this one, okay, you want to see this so-called average value come from which baseline? Okay, then you need to come to here. Click on this so-called average point class. Okay, and then there's a pen. Okay, you click on it, then you see this CP02 3D and this from this two station. Okay, this station process have one result, and the CP1 process CP2 there's another result, and this the result of the measurement. Okay, 3D CQ. Okay, and this the coordinate. Okay, and this the average value. Okay. Okay, so for this case, when I see this case, when there is no exclamation mark, most of the time it's okay. If have cases, this have an exclamation mark here, okay, then what you need to check, you need to go to here and press the pen. You need to know which baseline have a problem. Then you need to go back and check your baseline, okay, whether it's the problem. Okay, Katie is just now pointing out why the exclamation mark here is not go away. Because it's really because that reference station, or just now we had to download from that reference station. That reference station don't have this navigation file. Okay, and that's why it failed. Okay, by right it should go away. Okay, if that reference station they have the so-called the Beidou tracking, then it should go away. Okay, so we can see all is the Beidou. Okay, so I'm sorry, but this is the fact. But just now you can see the R, the growness is go away. Just now there's exclamation mark there is showing the growness, and now growness because we import the so-called navigation file with growness. That's why it gone away.
So in this case, by in advanced,
right? Data, okay.
Data.
Yeah. Okay. No problem. We quickly gone through. Okay, so we do the processing again, but this time because this baseline take quite a long time, so I change to I'm not using okay, I want faster, that's why I just choose like this. So I go for processing. After processing, the Beidou, I mean the exclamation mark gone away. Okay, now you can see that there's a no exclamation mark anymore. Okay, then you just, if you want to store, then you store. Okay, I don't want to store because I did everything here already. Okay, so I hope it's clear. Okay, it's really depends on. So when it is important when you do the processing, you should know those so-called reference station or base station, what the satellite tracking they have. Okay, for the O1, most of the times are GPS coordinates only. Okay. Okay, I think for baseline processing is up to here. Okay, I quickly show the PowerPoint slides to you. Okay, this telling the after this the slides it talk about the definition, what the description of the number of ambiguities, what's the fixed, what's the total, and give you some information. Longer data set with a high number of ambiguities. Okay, all this will show up. Okay, what's the fixed? Okay, and what is supposed possible fix. Okay, all this will show up here. So you take your time. Actually, I gone through already just now. You take your time to read the PowerPoints. Okay. Okay, I have a quick. So want to go into, okay. Any question about the baseline processing? Any questions? Because I would like to go to another topic. Okay, but today's about GNSS processing will be up to here. So any questions for the processing? Any questions? No questions? Wow, okay. Normal. Okay, so never mind. If you have questions, please send the email or let us know. Okay. I guess this is a quite hot topic, especially in the Southeast Asia. Okay, about the processing, you need to master it. Okay. So the next one I would like to talk about is the support cases matter or support matter. Okay. I'm not sure. You guys have this called XP key. Okay. There's inside XP there's a lot of technical information. Okay, can help you to understand better about our instruments. Okay, and for example, there's like the ME, the measure engine method version 4. You may face this problem, this question from the customer. Okay, and we have very detailed information is inside in XP. Okay, actually what we do also, if when we send, before we send to Switzerland the questions, we also go to XP to try to find out the solution by ourselves. Okay, so make sure you can access to XP, otherwise please let us know. Okay, because you should have access to this XP about the really detailed technical matter. Okay. Another thing is about when you send in the support cases, please include the instrument serial number or the software EID if you have. Okay, if you have. Okay, because we really need to link these cases to the instrument or the software. Okay, so that we can do better analysis what is happening to the specific product. Okay, and also when you send the questions, sometimes maybe the language description is not good enough. I mean, for both probably from you and probably from us also. Okay, so if you have pictures or screen captures, definitely will help us to understand your problem, okay, in better way. Okay, so please, if you want to describe the problem, okay, you can use the picture, okay, highlight those problem you have, okay, and then from the screenshot, whatever a picture, then we know what is the problem is, okay. Otherwise, the lengthy email also doesn't answering the questions. Uh, Other things about the queue, okay. Actually, we have a two support email. One is a first technical support AP, okay, and this is really look after geomatics for like total station, GPS, level, infinities, okay. So let's say you have the scanner problem, okay, please send to the Asia HDA support, okay, and not send to this first technical support email, because at the end we need to kind of classify the product. Okay, if you send in the first, you send in clearly, then we have less work to do. Okay, so we can save our time. Okay, be more productive. Okay, I hope this points is clear for you. Okay, any more questions about this support matter? Okay, this Katie just remind me. Okay, okay. For now, I think the management a bit different. For the support team, we really don't hold any pricing. We support team, we don't hold any pricing. If you need about some pricing matter, please ask the salespeople, okay? Wherever the region, wherever the SUSG, okay, you should really ask the price from your sales manager, okay? Any questions? Any questions?
No,
Fine.
no,
Now,
not now.
any
Yeah, I
questions?
need to. No, I need to practice maybe and have question later.
Okay, sounds good, fine. Okay, you put the right strategy, practicing more.
Yeah,
Okay,
I need
so
maybe a question later.
okay, later I will upload those the so-called PowerPoint and other so-called sample data. Okay, you can try out yourself. Okay, you can try out yourself. Okay,
Yeah.
okay. If not, then I should say thank you very much. There's one more thing I would like to tell you. Okay, I would like to say goodbye to you guys. Okay, because I'm leaving Leica Systems. Okay, uh, so but no problem. And Christine still behind. Okay, supporting all your activities. Okay, okay. I hope can see you again. Okay, in the future also. Okay. Any more questions? Okay. Christine say you guys crying. Okay, if you know, thank you very much for your attention. Okay, Christine and Katie, any?
Thank you, everyone.
Thank
Wow.
you.
Okay, okay, thank you very
Thank
much.
you, Alex.
Thank you your attention. Okay, I hope can see you again. Bye.
Appreciate a lot.
Where is the? Yeah.